Hello everyone, my name is Cynthia Tanchai Ping, and today I will be presenting my final project for visual programming. The title of my project is Dreamscape Symphony. For this project, I chose the dream pop aesthetics. I really like dreamy and relaxing visual styles. Dream pop usually features soft colors, glowing lighting, floating elements, and peaceful emotions. I was inspired by fantasy skies, stars, clouds, oceans, and whales. These elements became the main visual language throughout my project. My project is called Dreamscape Symphony. Instead of telling one complete story, I designed 3 connected dream scenes. Each scene represents a different stages of a dream. The first scene is about entering the dream. The second scene lets the audience interact with the dream. The final scene brings the audience into a peaceful dream ocean. My goal was to create a relaxing and immersive experience using different generative techniques in TouchDesigner. Before building the project, I collected many Dream Pops references from Pinterest. I mainly looked for dreamy skies, glowing moons, colorful clouds, fantasy oceans, and whales. After deciding the visual direction, I built each scene separately in TouchDesigner, and finally combined them into one project. The first visual is called Dream Moon. This scene creates a calm and peaceful atmosphere. The moon slowly swings left and right while gently glowing. Clouds continuously drift across the sky, and small stars slowly float in the background. Everything moves very slowly, because I wanted viewers to feel relaxed while entering the dream. To create this scene, I used several TouchDesigner nodes. Background starry sky. Noise top generates noise texturizes raw material for the nebula, while level top adjusts contrast and applies multiple layers of noise are stacked to enrich details. Feedback top creates a dynamic trailing effect. Displacing top distorts the flow to produce a drifting nebula, and slope top detects edges to sharpen outlines. For the scattered stars, noise top generates random noise as raw material. Then level top adjusts contrast, darkens shadows, and brightens highlights to filter out star-like spots. Finally, channel mix top removes black background by making it transparent, allowing stars to blend cleanly over any background. Moon creation and loop effects. 2 circle tops are used. The large circle serves as the moon body, and the small circle is offset, and combined with composite top using outside mode to cut out a crescent shape. Noise top generates surface texture, and level top turns its yellow. Bloom top creates moonlight with gentle flickering. Blur top softens the glowing edges. Level top adjusts brightness. Transform top adds an expression for gentle looping swings. Cloud creation and texture. Multiple circle tops serve as basic cloud shapes, with transform top positioning each circle and composite top blending them in add mode to form a single cloud. Noise top adds texture details. Level top adjusts contrast to solidify the cloud. Slope top sharpens outlines. Displaced top keeps edges drifting. Blur top adds dreamy softness. Ramp top adjusts color. And constant top adds transparency. Clouds are duplicated, some sitting still below the moon. In the node's parameter panel, I adjusted the speed value to set the cloud movement pace. Then I enabled the limit option and set its range. This forces the clouds to reset to the starting position once they pass the limit, creating a seamless, repeating loop. The second visual is called Singing Stars. This is an interactive artwork. The mouse cursor is transformed into a cloud. Whenever the cloud touches a star, the star rotates and plays its own musical notes. Users can freely create different melodies by touching different stars. 3D stars. 3D star models downloaded from the internet comps are placed in geometry. Transform each star with comp positioning. Feng Mat assigns different colored materials to each star. Rendering top renders the scene, and Bloom top makes the stars glow. Star gentle swing. LFO chop selects a sine wave to generate a swing signal. Math chop uses multiplier to adjust the swing amplitude. And null chop exports the velurotate parameters to the star's transform, allowing the stars to gently swing in place. Cloud creation and interactive. The method for creating clouds is the same as before. Mouse in chop captures mouse click or hold data. Level top controls opacity to show clouds based on mouse input. Feedback top creates flowing trails when the mouse moves. Blur top softens the texture to prevent overcrowding. Edge top extracts texture edges. And level top adjusts opacity to control texture density. Collision detection. Stars and clouds are connected through a composite top multiply mode to create overlapping intersections. Analyze top detects the overlap area, limit chop sets the trigger threshold, and trigger chop converts the continuous collision signal into a pulse trigger. Sound note. Each star is assigned a different pitch through select chop. The collision signal is connected to the Q pulse input of the audio file in chop, triggering the corresponding audio file to play in full upon collision, achieving a unique sound for each star when touched. Collision rotation effect. After collision triggers, Math chop sets the rotation value to 360 degrees. Lag chop smooths the rotation transition. Chop exports the data to the star's transform rotate parameter. The last visual is Dream Ocean. This scene combines generative animation with audio reactive effects. The ocean surface reacts to the music in real time. Several colorful whales continuously jumped across the waves. The combination of movement and sound creates a magical dream ocean. Ocean surface waves and coloring. Grid SOP serves as the ocean base, with transform SOP rotating it to face upward. Top to chop converts the noise to data, selects the text or tie channels. Noise top generates wave noise for the ocean surface, creating ups and downs based on the noise's black and white values. Ramp top creates an ocean gradient color, and Fong Mat applies the material, completing the colorful waving ocean surface. Audio-driven ocean waves. Null chop exports to the ocean's displace or deform parameters, making the ocean waves and pulses with the music rhythm. Lag chop smooths the wave transitions. Analyze chop extracts specific frequency data such as bass for big waves, whale coloring and jumping animation. 3D whale models downloaded from the internet are placed in geometry comps. LFO chop generates a looping jump signal. Select chop selects the text horizontal, tie vertical jump, and rotate rotation channels individually. Math chop adjusts the value range and direction for each channel. Chop exports to the whale's transform parameters, combining to create a parabolic jumping Matthias. The whale leaps out of the water in a continuous loop. Throughout this project, I explored how animation, interaction, and audio reactive visuals can work together to create an immersive experience. Rather than creating 3 separate artworks, I wanted them to feel like different stages of one dream. From the glowing moon, to the singing stars, and finally to the dream ocean. Each scene invites the audience to slow down, explore, and enjoy a peaceful fantasy world. Thank you for listening.